Hello and welcome. In this video I'll be covering section 4.6, which is over polynomial inequalities as well as rational inequalities. My goal for you by the end of the video is to be able to solve polynomial inequalities as well as solve rational inequalities. So we'll start with dealing with polynomial inequalities. One type that you guys have already dealt with is what was called a quadratic inequality, which was something that could be written in this format of ax squared plus bx plus c being greater than 0 or potentially any of the other inequalities such as less than or greater than or equal to or less than or equal to. So quadratic inequality that you've encountered in the past essentially was just one single type of a polynomial inequality. Essentially what we'll do though is a very similar approach where I'll want to just get one, like a 0 on one of the sides, and we basically will treat the inequality as if it's an equal, solve for the zeros, and then use those numbers to break up a number line. So again, we can solve by plugging those in, or plugging in numbers that fall between our key or critical values, which would be essentially just the x-intercepts, because after all, a graph could potentially change sign at one of those x-intercepts, meaning going from, if I were to actually graph it, from being above the x-axis to then being below the x-axis. So you can also somewhat kind of sketch a rough estimate of what the graph would potentially look like, where you take into account any sort of multiplicities as well as what the end behavior would be. But really, ultimately, one of the easiest ways to do it is just pick numbers that fall in between the values, plug it in, and just look to see if it comes back positive or negative. So hopefully this is a decent review of how to do that, but this first example is just a recap of what we learned a little bit earlier in the year. So recall with an example such as this one, where it is a quadratic that's now, it says for this scenario it's greater than 0. Our first instinct was to try and factor it. So with this, it would be what multiplies to a -5 that would add to a -4. So if I need to add to a -5, but multiply to a -5 and add to a -4, that's got to be a 5 and a 1 somehow, some way. In this scenario, it would need to be a -5 and a +1 to satisfy those two statements. So our critical values happen to be whatever makes those two things equal 0, or those two factors equal 0, which in this scenario would be a +5 and a -1. And recall from earlier, we would then just take those numbers and roughly sketch them on a number line, and then we would pick some random numbers that fall on whatever those values would be. So for this example, being less than -1, one possible number I could plug in would be something like -10. If I plug that into each parenthesis, I'd have -10 minus 5, which is going to be negative, and a -10 plus 1, which also would be negative. But when you multiply two negatives, I actually get a positive result. So that part of the number line would technically exist above the x-axis is how we can interpret that. Something that falls in between -1 and +5 would be a number like 0. So if I plug 0 in, the first parenthesis would come back -5. Second parenthesis would be a +1. A negative times a positive comes back negative. So I know that portion of the graph must dip below the x-axis or have all negative y values. If I move on to the last interval, something greater than 5, an example like +10 would work. If I plug +10 into my two factors, I get a +5 in the first one and a +11 in the other. Two positives, when you multiply, remain positive. So at this point, we now take our number line. We've got our pluses and minuses for the parts that would be above the x-axis or below the x-axis. And we now reference back to the original inequality. This says I want to be greater than 0, which that then means I want to be positive. So now I'll look at the test intervals that I had and look for which ones came back positive. Keep in mind negative infinity is as far left as possible and positive infinity is as far right as possible. So the solution for this particular one would be the intervals from negative infinity until -1. I would now look at the inequality to see if I can equal -1, which this one does not have the or equal to, so I'll use a parenthesis to make sure I don't include the -1 in my solution. And then combine that with the second interval, which started at 5 and goes on to infinity, where again I left 5 out because I did not have the or equal to. And there would be my solution set for this particular problem. Now a different way we could have approached this was more think of what's the shape of the graph. This happens to be a parabola that opens vertically, so I could have also just pictured a parabola that has those x-intercepts and just look for which parts satisfied the inequality, which in this case being positive would mean it needs to be above my number line. And notice the graph portions that happen to be above the x-axis, or this number line here, happen to be the same intervals from negative infinity to negative 1, as well as from 5 to positive infinity. So our approach is essentially going to be very, very similar to what we did with the quadratics as I presented in the last example, in the fact that I still am going to want to get 0 on one of the sides. So this is more of a just breaking it down into a a step-by-step idea, so we can just follow through with here's what I need to do first, then this is what I need to do second, and so on and so forth. So again, first start with moving everything to one of the sides of the equation. My personal preference is always to move everything to a side that would make the leading coefficient positive, or the highest powered term be positive, in other words. So I always base my decision on which side I move things to, essentially on what sign the highest powered term has. Once I get it there, then I solve the related polynomial equation, which basically means set it equal to 0 and solve, which at this juncture usually means I'm going to probably have to factor. So once you get the factored form, you then could set each individual factor equal to 0, solve, and then set up your number line by breaking it up into multiple intervals. The other option would be to utilize the end behavior and just sketch a rough graph of how it would pass through each of those x-intercepts, keeping in mind multiplicities would matter, and then look for whichever parts satisfy the inequality, whether it needs to be above or below. Kind of depends on, do I see a greater than or do I see a less than? But again, we always want to be comparing with 0. That way, really, ultimately, all I need to do is, if I did the testing intervals, just figure out which parts come back positive, because all positive numbers are above 0, and which parts come back negative, because all negative parts would be below 0. Once I've set that up, I also then would answer my solution set in interval notation or potentially set notation. Personally, I think interval notation is easier because you can just utilize the number line and just work from left to right. Just keep in mind that if you have the or equal to, that's when you'd end up utilizing brackets. So if you have or equal to's, you'd end up with brackets. If you don't have the or equal to, in other words, if it was just a greater than or a less than, in that scenario you would end up using parentheses next to those numbers depending on what order you needed to write it. But remember, intervals always will go small comma big, or you can also think of that as left comma right. So let's go ahead and work through a few examples. So with this first one, notice I don't have 0 on one of the sides, so I would look at where is my highest power term. In this case, it's positive x squared. Since that already is a positive term, I'm going to decide to move everything towards it. So since that's on the left side, I'm going to move everything that's on the right over to the left. So the two steps I would have to do is subtract x, that way that x cancels, and then also subtract 3, that way it cancels, and then combine it with whatever like terms I end up having on that side. So notice there wasn't anything to combine with the x squared, so it's going to remain. A 3x take away an x would actually turn into a positive 2x, and then a negative 5 take away 3, that would turn into a negative 8. And now I have it less than or equal to 0, so the or equal to means I'm more than likely going to utilize brackets, so you can kind of save that information for later. And also being less than 0, I'm going to look for negative parts, or in other words, parts that drop below the x-axis if I were to maybe sketch a graph. So this one, again, I should be able to actually just factor. So what multiplies to a negative 8 that adds to a positive 2? That would be a positive 4 and a negative 2. So my critical values in this case, or you can even just call them critical numbers for this scenario, are going to be a negative 4 from the first factor and then a positive 2 from the second factor. So I'll go ahead and set up my number line. Negative 4 would come first, so that's going to be the left number, and then positive 2 is the right number. If I think about the shape of this graph would be something that would open up because the leading coefficient was positive. So I could now look at this and just go, well, okay, well, the graph would look like that. The part that was below 0 is the part that fell below this line, so that would be from negative 4 to positive 2. But if you didn't know the shape of this graph for whatever reason, what we could do at this point is just test with some numbers. So if I plug in -10, for example, that would be to the left of -4. If I put that into the factored version here, -10 plus 4 would be negative. -10 take away 2 would also be negative, and two negatives when you multiply would give me a positive. The number that would fall, or that I would probably choose between -4 and +2, well, 0 is between all positive and negative numbers, so that would be an easy one to plug in. First parenthesis would be +4. Second parenthesis would be -2. A positive times a negative would give me a negative result, so I know that part must dip below or give me negative values. And something greater than 2, I could plug in something like 5 or 10. I'm just going to choose 10. 10 plus 4 would be positive, 10 minus 2 would be positive, and two positives when you multiply give me a positive. So notice in each of these scenarios, I'm not really looking at what the exact value is. I just need to figure out would it be a positive result or a negative result. So my final answer for this one is going to be, again, the interval I wanted to be less than 0, so that's going to be the -4 to +2 because of the or equals to, or equal to. I'd end up utilizing the bracket as I mentioned earlier, so both numbers were allowed to be a part of it because that's where they would equal 0. So there would be my final answer, the interval from -4 to +2, where I include both endpoints. So now we'll go ahead and transition into something that's not quadratic. So since our first two examples were quadratic, I'm hoping that that means we have a general idea of how we can approach those. Now that I have something that's not quadratic, this one would be actually considered a cubic function because the degree is 3. I still am going to start the same way. I just try and factor in some way, shape, or form. This particular one I can actually do a little bit easier factoring than doing the P over Q method because they both have an x, so I should be able to factor x out, which then leaves a quadratic x squared minus 1 that then can factor even further into a difference of two squares, or a conjugate pair of what multiplies -1 that adds to 0. Well, that would be a +1 and a -1. So again, identify the critical numbers, which in this case would be from my first factor out front. If x was 0, the whole thing would be 0, so that's one of them. X plus 1, set that equal to 0, I get -1. And x minus 1, set that equal to 0, I get +1. So setting up a number line, I would just have three numbers this time. -1 would come first, 0 would come second, and +1 would come third. And just try and pick some numbers that I can test with. So -10 seems to be a pretty consistent number that I get to use here. So -10, if I were to plug it in, would be a negative out front, a negative in the first parenthesis, and a negative in the third parenthesis, or second parenthesis, sorry. And that would be three negatives multiplied together, which would come back negative. If I plug in something between -1 and 0, maybe -1/2, the front number would be negative. -1/2 plus 1, that would actually go positive. And -1 take away 1, that would be negative. So total, I had two negatives that would be multiplying together. Two negatives should make a positive. Plug in +1/2. Let's see what happens here. The first term out front would be positive. Adding 1 to it would also remain positive, but subtracting 1 from it would become negative. So I've got two positives times a negative, that would come back negative. And the last one, maybe plug in a number like +10. Feel like everything's going to be positive, which in fact it is. Three positives when you multiply remain positive. So for this one, I was looking for parts that were just greater than 0, so there's no or equal to. So then that means I'm going to use parentheses on any interval I write. If I look for which ones came back positive, it was the from -1 to 0. Again, parentheses, because I'm not supposed to equal 0. And then after that, looks like the second one started at 1 and would go on to infinity. So that would be my solution set for this particular problem. Now, if you wanted to think of this more graphically, we could also have looked at this and said, well, I know my degree is odd, so the arrows point opposite directions. The leading coefficient is positive, so that means the arrow on the left would point down, the arrow on the right would point up. And then each of those, notice the multiplicities on each would be a multiplicity of 1, so technically I would just pass right through each of those x-intercepts. And so if I connect the dots, I can look to see which parts were above. Notice that confirms the -1 to 0, as well as the 1 to infinity as the parts that actually were above our number line. So again, two different approaches. I think the testing with numbers is a little safer because you don't have to know as much about the graphing portion, but if it makes more sense for you to just sketch a really terrible graph of it. Just make sure that you're following suit with what multiplicities are supposed to happen, as well as what the arrows should do at the end. That also is one way that you could come up with, I guess, arriving at your final solution. All right, moving on to our third example, third and actual last for these polynomials before we switch to the next concept. Again, with this, notice I have a power of 4 as the highest power, so this is probably going to require a p over q since I don't know any factors right now. Since that term is positive, though, I'm probably going to move everything to the left, so I'm going to go ahead and subtract 4x cubed from both sides, which there's nothing to line it up with, so it's just going to stay a negative 4x cubed. And then add 8, which there's no constant on this side either, so the adding 8 really is not going to have anything to go with either. So I'd have 3x to the 4th minus 4x cubed. I'm going to rewrite this in descending order. Then minus 29x squared. And I've got a minus 14x. And then the plus 8 for my constant. And now all of that would be less than or equal to 0. So some things that we could start to do is list out the p over q values. So my p over q's in this case are factors of 8, which would be a 1, a 2, a 4, and an 8. And list it over any factors of the leading coefficient, which in this case was the 3, so plus or minus 1 and plus or minus 3. And if we wanted to separate all those out, I'd have 1, 2, 4, and 8 with plus or minus symbols in front of them by putting it over the 1, and then 1/3, 2/3, 4/3, and 8/3, both positive and negative. That would be options as well. So as far as how do I go from here, well, essentially it's just going to be set up synthetic division, and just from that list of numbers do a little trial and error. So I'm going to go ahead and just start with potentially one of the easiest ones to try, which would be a positive 1, and just see what happens. So first number, remember, drops, then I multiply, and then I add, and then I multiply again, and then I add, and I multiply again, and I add, and it seems like this one is not going to come out as a negative 8 like I want it to, so positive 1 was not a good try. However, maybe negative 1 will come out a little better, so let's try that one. So 3 times negative 1, negative 3. Add that up, I get negative 7. Negative 7 times negative 1 is positive 7. Add that up, I get a negative 22. Negative 22 times a negative 1 is positive 22. Add that up, I get positive 8. So it looks like this one's working. 8 times negative 1 is negative 8, and yes, in fact, it did work. So as far as listing out some critical numbers, I'm just going to do that here in the top right. Critical numbers so far I found were negative 1, and let's see if we can find another one. So notice I'm not starting completely over, I'm just making a new synthetic division. Since I divided once, my degree at this point with those coefficients of 3, negative 7, negative 22, and 8, now that has a degree of 3. If I can divide one more time, it would turn into a degree of 2, which is a quadratic that then hopefully I can factor. So let's see, what are some other options to try? I feel like negative 1 worked, positive 2 got pretty far away, or positive 1 got a little bit further away. So I'm thinking maybe negative 2. Let's just try it out, see what happens. So with this one, drop the 3, multiply, so negative 6, that would give me negative 13. Negative 13 times negative 2 would give me positive 26. That gives me a positive 4 times negative 2 is negative 8. Hey, I got lucky again. So at this point, we can go ahead and rewrite this utilizing the x's again. And realize that I'm just trying to solve for when does that equal 0. I did identify another critical number by finding a 0, which was negative 2. I should potentially have 2 more to go, so that's probably going to come from this quadratic. So I'll do the normal quadratic strategy here of multiply those two. I need to multiply to 12 and add to a negative 13, so that seems like it's going to be a negative 12 and a negative 1. But because of the coefficient of 3, I'll divide them both by 3 and get x minus 4. And let's see, that one would be a 3x minus 1 if I go ahead and move that denominator over. So it looks like my last two critical numbers are going to be a positive 4. And then the second one, if I set it equal to 0, I would add 1, then divide by 3, so positive 1/3. So setting up my number line, I can go ahead and put 4 tick marks on it this time. Smallest out of those was -2, followed by -1, followed by 1/3, and the last one +4. And now let's go ahead and test. I could rewrite this in factored form utilizing those zeros, so that means I'd have x plus 1, x plus 2, I'd have x minus 4, and the last one was the 3x minus 1. So again, if I'm looking to see which parts are negative, I can plug into this factored version relatively easy. The other option I could do is just think of the end behavior. The arrows in this case, because the degree originally was even, should point the same direction. And since the leading coefficient was positive, they should point up. So I could actually sketch a graph and just go, well, I know the arrow on the left will point up and the arrow on the right will point up. Every one of those zeros only happened once, so they have a multiplicity of 1. So that means I should be able to just cross through. And notice I am able to connect those arrows if I do that. And if I'm looking for the parts that are less than or equal to 0, it would be the 2 parts that actually drop below the x-axis. So for this one, it seems like my solution is going to be -2, -1. It does have or equal to, so it's going to have brackets on this one. And then combine that with the second interval, which looks like is +1/3 to 4. And again, include both of those because it's okay to equal 0. So my solution set for this one would be right there. If you wanted to do this more with the testing using numbers, we could also plug in numbers like -10 and just look at each parenthesis to see what happens. Each of them would come back negative in this scenario, but 4 negatives multiplied together would come back positive. A number between -2 and -1 would be like -1.5. If I plug that in, -1.5 plus 1 would be negative. -1.5 plus 2, that one would be positive. And the other one, since I'm subtracting away from it, those would be negative, so I'd end up with 3 negatives, which gives me a negative result. A number between -1 and +1/3 would be like 0. Plug that in, I get positives with the first 2 parentheses, negatives with the last 2 parentheses, so only 2 negative signs, but when I multiply 2 negatives, that would give me a positive, so that would come back positive. Something between 1/3 and 4 would be like maybe 2. 2 plus 1 is positive, 2 plus 2 is positive, 2 minus 4 is negative. 2 times 3 would be 6, take away 1, that's going to stay positive, so I only got 1 negative sign, so that would come back negative. And a number greater than 4, like +10. Adding 1 would be positive, adding 2 would be positive, taking away only 4 would remain positive, and then multiplying by 3 and only taking away 1, that one would be positive. So that would be 4 positive numbers multiplied together, which gives me a positive. So notice the picture or the sketch that I had also is confirmed with the test values that I plugged in as far as which parts were above and which parts were below. So again, either of those strategies you can go through and do. The sketching may be faster, but again, it does require you to know a little bit more about like the end behavior as well as having to worry about multiplicities. So if you're comfortable with those 2 concepts, have at it. Go ahead and just sketch it like I did initially to come up with our solution, or do what I did the second way, which was pick some numbers that fell on the interval, plug it in, and see what results you get. So now we'll transition into the second concept, which was the how do I solve rational inequalities. So with this, ultimately remember rational functions are polynomials over polynomials. So essentially what these will look like is just a rational function somewhere in our equation, or inequality rather. So our goal still is going to remain the same. I still want to get 0 on one side of the equation. So if you don't have 0 on one side, just subtract the entire fraction over, or if it's just a constant, subtract the constant over. But essentially what we'll have to do after that is find a way to combine it as one single fraction. So that means we'll have to find an LCD and then change both fractions to have that LCD by multiplying top and bottom by some factor or some number until they actually all have the same denominator. Once they all have that same denominator, I should be able to combine it together. The numerator more than likely will have some like terms that you'll want to combine, and after you do that you may want to factor, because the next step we'll have to actually set the top equal to 0 and solve. And then we'll also set the denominator equal to 0 and solve, so you'll want to keep the denominator also in a factored form. Ultimately, the list of all of those numbers from step 2 and step 3 are things that we would call the critical values, or you can also call it critical numbers. And those would be the same as what we were doing with polynomials. We would just put those on a number line and think in terms of what should the graph really look like. In these scenarios, the graphs are a lot harder to kind of figure out what actually is happening. So it is something where you really are going to want to do more of the, let's just pick a number that's on that interval, plug it in, and test it, and just see if I'm going to get a positive value or a negative value when it's all said and done. Once we get all of the pluses and minuses on our grid, at that point we can then look at the inequality and just see, do I want to be the positive values? In other words, do I want to be greater than 0, or do I want the negative values, such as I want it to be less than 0? For anything that has the or equal to, the only numbers that we can include are ones that came from the numerator. Keep in mind that anything from a denominator that makes it equal 0 will never, ever, ever be included because they are left out of the domain. So if it helps for you to identify the domain right off the bat and just see what those numbers happen to be, just remember in the end, those numbers will always get a parenthesis next to them. So the ones that are never included will get parentheses. The ones that would be included, once again, would get like our brackets next to those numbers. So it could be a bracket to the left or a bracket to the right, depending on how that interval is set up. So it is possible with this scenario for you to have one side have a bracket, but the other side have a parenthesis, and then just have your two numbers that fall in between. Okay, so for example, if I had like 4, 7, I could go ahead and say, well, 4 was included because maybe it came from the numerator, or it made the numerator equal 0, whereas 7 came from the denominator or made it an undefined value, so I'd make sure that I get rid of it. So that's just a random example with numbers, but again, notice the order in which I wrote that was small, big. Just remember it always goes left, right, or small, big. So to practice this concept, we'll start with a relatively basic example here where notice I've already got the 0 on one side, so I don't have to do any movement. And it already actually is as factored as can be, so with this one it would just be set the top equal to 0 and solve, which in this case I would just get x equals 0. And then set the bottom equal to 0, which in this case I would just have to subtract 6, so I'd get x equals -6. So I use those two numbers, the 0 that I found and the -6 that I found, and set up a number line. Plug those in, or put those on there, so small one comes first, second one goes, the bigger one goes second. In this case, if I were to choose a number less than -6, once again, -10 seems like a good number to try. If I plug that into this fraction, the numerator would be negative, and the denominator would be negative, so I'd have a negative number divided by a negative number, which would come back as a positive value. If I choose a number that falls between -6 and 0, for this example, I'll just choose -3, but you could use -1 or -2 or -4 or -5. Any of those numbers would be good ones to try. If I plug that in here, it looks like the numerator, 3 times a -3, that would remain negative on top. A -3 plus 6, that would be a positive on the bottom. A negative divided by a positive gives me a negative result. And then after 0, a number like 5 would be something that I could plug in. I could stick with my normal 10 if I really wanted to, but I'll just change it up. I'll use 5. Plug 5 in, I get 3 times 5 is positive on top. 5 plus 6, that's positive on the bottom. Two positive numbers when you divide should still give me a positive result. So I'm looking for, in this scenario, something that's less than 0, so I can't equal it, so that means it's going to be parentheses everywhere. And I'm looking for negative values, so it looks like from my sign line here, there was only one part that actually gave me a negative, so my final solution for this one is going to be that interval from -6 to 0, where I just make sure I don't include because, again, it did not say or equal to. Now, as far as being able to sketch a graph of this, if we wanted to, we could have for ourselves just said, well, there's a vertical asymptote at -6 because that's where it was undefined, whereas it was an x-intercept at 0. If I were to sketch this, I would expect this graph to probably look something kind of like this. Again, that's probably not something that would be an obvious thing. We would need to do like a T-chart or a table anyway, hence why with these rational inequalities, it's a little bit better to actually just pick some numbers, plug them in, and just see what kind of values you get. And ultimately, you're just going to be counting negative signs. Remember, an even number of negative signs would come back as a positive result. A negative number of negative signs, an odd number of negative signs would come back as a negative result. With this next example, we're going to ramp up the level of difficulty a little bit. Doesn't seem like it's a whole lot different, but notice this time I don't have the 0. So with this one, the first thing I would want to do is get 0 on one side. The easiest way in my mind to do that would just be to subtract that 1 over. So now I'd have x plus 1 over, I'm going to go ahead and factor the denominator and take the 2 out of that and call it a 2 times an x minus a 2. And then I have the minus 1 after it, but now it's actually less than or equal to 0. So I've at least got the 0 part taken care of. At this point, I would need to get a common denominator. Well, I could picture 1 like it's 1 over 1. So the common denominator in this case really is just going to be the only denominator I see, which would be 2 times 2 minus 2. And so by multiplying top and bottom by 2 times 2, or x minus 2, that should now give me a common denominator, so I can write it as a single fraction over that 2 times x minus 2. And then in the numerator, it looks like I'd have an x plus 1 minus the 2 times the x minus 2. So it looks like I'll just have to distribute a negative 2 through my parenthesis to be able to combine like terms. So if we go ahead and kind of combine those steps, I'd have an x with what looks like a negative 2x, so that should give me a negative x. And then I've got a 1 with a negative 2 times a negative 2, so that would give me positive 4. So 1 plus 4, that would give me a positive 5. And then still over the 2 times x minus 2, and still being less than or equal to 0. So at this point, I would set the top equal to 0 and set the bottom equal to 0. So I'll go ahead and do that over here on the top right. If I set negative x plus 5 equal to 0, instead of subtracting 5, I think it's smarter to actually add the x over. That way it just becomes a positive term already. So 5 would equal x. So there's one critical number. And then the second one, if I set it equal to 0 on the bottom, I really don't need to worry about the 2 that's in front. It's really just going to be when does x minus 2 equal 0, which in this case would just be add the 2 over, and I'd get that my critical number from the bottom is going to be x equals 2. Now, if we look at the original inequality, or even the final inequality, this does have the or equal to, so keep in mind that this 2 came from the bottom, so I need to make sure that I take note and know that I'm going to exclude that number anytime I use it with an interval, so that's going to have a parenthesis next to it. The 5, on the other hand, I get to include, so whenever I write an interval that has a 5 next to it, that number is going to get a bracket next to it. So let's go ahead and set up the number line with those critical numbers. 2 is smaller than 5, so it would go further left. And let's test it. And I'll test it plugging into our final version, so this one that's down here in the bottom left. If I were to choose a number that's less than 2, I feel like 0 is a nice one. Plug in 0 on top, I get positive 5. Plug in 0 on the bottom, I get a negative 2 times 2, which is a negative result. A positive over a negative should give me a negative. A number between 2 and 5, maybe 3. Plug 3 in, I get negative 3 plus 5. That's going to be positive on top. 3 minus 2 is positive times a positive 2 is positive on the bottom. So I've got a positive over a positive, which should come back positive. And if I choose a number greater than 5, such as maybe 10, negative 10 plus 5 is going to be negative on top. 10 minus 2 is positive times a positive 2, so positive on the bottom. A negative over a positive would come back negative. So I'm looking for, again, the parts in this scenario that are less than or equal to 0. So I did have 2 intervals that came back less than 0. Looks like negative infinity until 2. And then the second one is from 5 to infinity. So this is now where, notice I didn't put any symbols next to the numbers yet. I'm taking a step back and looking at which ones should have a bracket, which one should have a parenthesis. Well, infinity and negative infinity always get a parenthesis. 2 I was supposed to exclude, so that's going to have a parenthesis, but 5 I was supposed to include, so it's going to get a bracket. And then just separate it with the u in the middle to say that it's the combination of those two. And there we go, we found our solution set for this one. And moving on to our last example for the day. Notice this one is amping up in level of difficulty that much more. In this scenario, it really does not matter which way I move. It's not like one side is easier than the other. So it really just comes down to personal preference. Which one do you want to move? So to move an entire term, keep in mind I would actually subtract the entire thing. So I'm actually going to subtract that whole fraction from both sides. And I'll just list it out horizontally here in the next line. I guess that should, I'll put the negative actually in front of the fraction. So this would be written as x minus 3 over x plus 4, and then minus the next fraction, which is an x plus 2 over an x minus 5. And at this point it would be less than or equal to, since I've completely canceled everything on the right side now is what has 0. So I've got the 0. Now I just need to find a way to combine these and make it a single fraction. Well, in this case, the LCD would actually just be the product of the two denominators I see. So if I multiply the first one by x minus 5 on top and bottom, that will give that fraction both x plus 4 and x minus 5, which then means I need to make the second one match that, so I've got to multiply it by an x plus 4. Notice at this point both denominators have an x plus 4 and an x minus 5, so I should be able to make this one single fraction with that as the denominator. Notice I'm not worrying about expanding that. I'm going to keep it actually in this factored form, because ultimately in the next step I'm going to set that equal to 0. That's a lot easier to deal with. Now what happened on top is I had the x minus 3 and the x minus 5 that I'll need to multiply. Then I'll have to subtract whatever the product of x plus 2 with the x plus 4 is. So if I actually distribute those things out, this first one I'd end up with x times x, which is x squared. I'd have a negative 5x and then a negative 3x as my next two terms, which should combine to turn into a negative 8x, and a negative 3 times a negative 5, which would give me a positive 15. The second one, because of the minus sign, I'm just going to take every result I get and just subtract it. So I'd have x times x, which is x squared, so I'm going to say it's going to be minus x squared. I'd have a x times 4 plus a 2 times x, so that would be 4x plus 2x, which is 6x, but again I'm subtracting, so it's going to be minus 6x. And then a 2 times 4 is the last part, which would give me 8, but again I'm subtracting, so minus 8. Then all of that still over. Notice again I'm keeping the denominator in this factored form. So from here I'm going to go ahead and move up so I've got a little bit more room. It looks like I have some terms I can combine. I've got x squared minus x squared, so those actually will zero out. I have a negative 8x and a negative 6x, so that will actually combine to give me negative 14x. And I've got a 15 minus an 8, which would be a positive 7. At this point, we could try and factor the top to its most simple version. Looks like to me, with that having a negative on that x term, I might take a negative 7 out, because 7 does go into both 7 and 14. So I could rewrite this as a negative 7 times, and that would leave a 2x from the first one. And if I divided 7 by negative 7, that actually will leave a negative 1 from the second term. You don't necessarily have to do that step, but it does make maybe the plugging in and testing part a little easier to do, because the numbers would be a little easier to deal with. But regardless, you could have left it in the same format as below. So if I set each of those part equal to 0, notice my critical numbers are going to be, from the top it would just be setting the 2x minus 1 equal to 0, which I would add 1 and divide by 2, so positive 1/2. If I set the 2 from the denominator equal to 0, I'd get a negative 4 from the first parenthesis and a positive 5 from the second parenthesis. And I'm just going to take note of both of these came from the bottom, so I need to make sure I exclude those numbers. The one from the top, it's okay. The 1/2 will actually get a bracket next to it if I write it as part of an interval. So let's go ahead and set up a sign line and throw 3 numbers on there, since I've got 3 critical numbers. Negative 4 is the smallest, 1/2 is the next, and 5 is the biggest. And now we're to the testing my intervals. So a number less than negative 4 would be, I don't know, negative 10, since that seems to be my I guess, preferred number to go with. 2 times a negative 10 would be negative. Take away more would be more negative. Then times a negative 7, so that would make the numerator a positive number. Negative 10 plus 4 would be negative. Negative 10 take away 5 would be negative, so 2 negatives on the bottom would make that positive. So it seems to me like I had a positive number over a positive number, which would give me a positive result. A number between negative 4 and 1/2, probably 0 is the easiest one I can think of. I'd have a negative 1 times a negative 7 on top, which would give me a positive value. I'd have a positive 4 times a negative 5 on the bottom, which would give me a negative value. A positive divided by a negative should come back negative. Something greater than 1/2 but less than 5, maybe 3. 3 doubled is 6, take away 1, that's positive. Positive times negative 7 would give me a negative number on top. 3 plus 4 is positive. 3 minus 5 is negative, so I got a positive times a negative on the bottom, so that gives me a negative. So thus far I've got a negative number on top divided by a negative number on the bottom, which would give me a positive result in the end. Then a number greater than 5 would be like 10. Plug in 10 on top, I get 20, take away 1, that's going to be positive, times a negative 7, so that would be a negative number in the numerator, over a positive 10 plus 4 is positive, 10 take away 5, that's also positive, so that would be over a positive number on the bottom. A negative over a positive would come back negative. So since I was looking for parts that were less than or equal to 0, I'm going to take my negative intervals and just set them up. So I had negative 4 to 1/2 was one of the negative ones. And then from 5 to infinity was my second one. Notice again I didn't put any parentheses or brackets yet. I'll go back and look at my numbers carefully. Negative 4 was supposed to be excluded, so parenthesis. 1/2 was allowed to be included, so bracket. And then 5 was excluded, so parenthesis, and infinity always gets a parenthesis. So there's my final solution set in interval notation. And I accounted for any of the numbers that I wasn't allowed to actually equal because of the domain restriction. Anywho, hopefully this video has been helpful in getting you to be able to do both parts of this section, both the polynomial inequalities and the rational inequalities. Obviously, the rational inequalities are going to require a little bit more fine-tuned detail when it comes down to it. We do have to find common denominators potentially and combine things. So there's a lot more work, more than likely, that's getting involved with these. But still, with even polynomials, sometimes you have to utilize the P over Q and do some trial and error with synthetic division. So I don't necessarily know which one you would maybe consider easier. They both have their level of difficulty, but again, key idea if you see the similarities between them is we want to get 0 at least on one side and try and find a way to get what values would be either equal to 0 or potentially equal to an undefined value, and then set up a sign line and just test each interval. If you can sketch a graph, like with polynomials, that's something that you could kind of picture how it should actually be sketched. By all means, you can do it that way as well, but with the rationals, it definitely is not something that it's obvious how the graph should be behaving. So anyway, hopefully the video has been helpful, like I said. As always though, if you have questions, just reach out and let us know, and we'll do whatever we can to try and make it make sense. I appreciate you guys taking the time to watch the video, and we'll catch you next time.